Hey, what's going on, guys? In this video we are going to take a look at the type of control systems. We have 6 types of control system. The first one is linear system, second one is non-linear system, and the third one is time variant system, and the fourth one is time invariant system, and the fifth one is linear time variant system. We can also call this one as LTV, I guess. Let me see. Okay, LTV. The short name for this is LTV, and this one is LTI, linear time invariant system. The shortcut name. Put it in the capital. LTV, LTI. Now we are going to see the difference between all these systems. Now linear system, what determine whether it's a linear system or not is basically the system obeys homogeneity and linearity. If it obeys homogeneity and linearity, this is a linear system. And if it's not obeying homogeneity or linearity, then it's a non-linear system. Now time variant system is basically if the output is varying with time. If the output is varying with the time, that is a time variant system. If the output is not varying with the time, it's a time invariant system. And then linear time variant system is basically linear system and time variant system are combined. It should obey the homogeneity and linearity. At the same time, it should vary with the time. If the output varying with the time, that's linear time variant system. But linear time invariant system is basically it follows the linearity. It obeys homogeneity and linearity, but the output is not varying with the time. So if it happens, it's a linear time invariant system. Now let's look at this. Let's see how to determine whether it's a linear or not. To determine linearity, we can give an example like this equation. Let's say we have a signal x of t. Let's put this on x1 of t. Signal goes through A1, and then we are getting an output of y1 of t, and that is equivalent to A1 x1 of t. Okay, this is first output. Now let's say we have another signal x2 of t that's going through A2, and then we are getting y2 of t. So we are getting the output as A2 x2 of t. Now what we are going to do is we are going to put an adder for this. So I'm going to use a different color. Okay, let's use black here. So I'm putting x1, these two signals together, x1 of t and then x2 of t through A1 and then A2. And then when we put an adder, we are gonna get the output is gonna be, let's say, y3 of t, and we know that x1 of t go through A1 of t is basically A1 x1 of t, x2 of t go through A2 of t, basically A2 x2 of t, and when we put the adder, these two are gonna just add up, A1 x1 of t plus A2 x2 of t. And that's going to be the output y3 of t. So y3 of t is basically equivalent to A1 x1 of t plus A2 x2 of t. Now that is A1 x1 of t is y1 of t, and A2 x2 of t is y2 of t. And if it happens, when we add these two signals together and we are getting the output of these two, it means this is following the linearity. This is a linear system. Now let's see how can we find out whether it's non-linear. Let's say we have another variable coming on in the output. Let's say we have A1 A3 x1 of t, A2 A3 x2 of t as a final output, and y3 of t is that A1 A3 x1 of t, A2 A3 x2 of t, and that is not equivalent to y1 of t plus y2 of t, because y1 of t just A1 x1 of t and y of t is just a2 x2 of t. We have just extra variable of a3. So it means this is not linear because this whole thing is not equivalent to the addition when we input these two signals. So that is not a linear system, that's non-linear system. That's how we can differentiate whether it's a linear system or non-linear system. I hope you guys find this video helpful. Thanks for watching. See you guys on my next video.